Welcome back, everybody. Today we will talk about data visualization using Matplotlib, not lib, it's lib, it's a type over there. So last week we have learned NumPy, and I believe you have a basic understanding of NumPy by now, because we also use NumPy exhaustively to create data, and we use that data to visualize it using Matplotlib. So let's just close this, or we can just keep it here. We don't really care. But first, as you can see, I have Anaconda. You should have also Anaconda. And then I have to open the Anaconda and just wait for some time. I have to wait for some time. I think by now the Anaconda Navigator is coming. As you remember, you have different tools, but we are in favor of notebook. Okay, let's launch the notebook. And as we have seen last week, it just gives you a navigation for the different folders on your computer. Since our project is on the desktop, so let's click this one. And I have this data analysis with Python. Oh yeah, great. So today is the 7th week. So let's create a folder, and let's rename this, and we can call it actually week 7. Yeah. So here we can create a Python file, actually a notebook. And I call this one, as I told you, it's good to give it a name. So visualization using Matplotlib. Great. Matplotlib. Yeah. So now you have this beautiful cell to run Python. Yeah, you remember print. I just love Python, don't you? And then shift enter. Yeah, it works. But this cell allows you to write code like this, or to leave some notes as a markdown. So we can just change this. I call it data visualization. Visualization using Python Matplotlib. Okay, great. Then I have to do this, or maybe we can do this. What are some of the packages we have? Some of the Python libraries, for data visualization are, can you tell me? Lovely. At least I remember this. But if you see, if you write just data visualization and then a Python libraries, here we may have Matplotlib, Seaborn, Plotly, Boken, Altair. I have never heard of this one. Folium, yeah, there might be many of them, but these are somehow very common. Yeah, let's also open this. 2016 is a bit too far. Matplotlib, Seaborn, yeah, this ggplot, but I think this is getting older. Bokeh, Bokeh, by the way, it's very interactive. It gives you interactive data visualization, much better than Matplotlib, if you know, and you can embed it with a website. Okay, that's good. Yeah, but Matplotlib, Seaborn, Bokeh, Plotly are somehow very common, and one might be better than the other. And sometimes when it comes to data visualization, one is better than the other because of some subjectivity matter. Okay, let's go here. Now here we focus on Matplotlib, okay? Matplotlib. As I told you, this Anaconda is so powerful, you don't have to install using pip now and then, because Anaconda has all the common packages, so you don't have to. But if you need, you just pip install Matplotlib. This is how you install it. Even we can install it over here by just doing this. Pip install Matplotlib, and just wait for some time. As you can see, it has been installed, and you can see it. Okay, so it's good to put installation also. This is just UI. This is how I write the markdown for a Python. Pip so Matplotlib. And now we don't need this. Then how do we import? Importing Matplotlib. Let's make a note, because it's good that I have to change this to Matplotlib. How do we import it? Import Matplotlib. This is how we import it. Now we imported the Matplotlib. Is it clear so far, guys, what I'm doing?
Yeah.
Great. But what is visualization, guys? Let's define data visualization. What is the definition of data visualization? And let's just take the data we got here. Wikipedia is now becoming a standard source of information. You know, at the very beginning, universities used to ridicule this. Yes, 10 years ago, as far I know that. But nowadays, even universities just do reference or cite for their PowerPoint presentation or lecture from Wikipedia. And I like the way Wikipedia represents information. Data visualization is an interdisciplinary field that deals with the graphic representation of data. The graphic representation of data. Okay, so what does that graphic looks like? It's a particularly efficient way of communicating when the data is numerous, as for example a time series. But I'm not happy with this definition. It lacks something for some reason. So I go for this definition. Data visualization is a graphical representation of information and data. That's really great. Yeah. By using visual elements. Have you seen? Visual elements like charts, graphs, and maps. Data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. This is a good one. And actually, it just makes easy for our brain to understand the data, even though the data is so big. And when we visualize it, make it so easy for the brain or for our cognitive to understand the pattern of that data and to get some insight. Yeah. So it's one step of data exploration. Okay, so that's the definition we have. So it can be data visualization could be a line, it could be a scatter plot, it could be a bar graph, it could be a histograph, or it could be a heat map, or it could be a pie chart, something like that, right? Great. So let's see this import Matplotlib. Let's see the version. Usually to check the version, we say just Matplotlib and then underscore version. Yeah. Yeah, we're using 3.32 and that's the version. I'm not sure if it's the latest version or not. Let's see. I matplotlib.org. What's the latest version? I think the latest 3.42. 3.42. What's ours? 3.32. We don't have to. We can go to the Anaconda environment and we can upgrade actually. Let's see, Matplotlib, as you can see, and then we can I think we can do it at the same time, I hope. Yes. Okay, then actually most of the time data analysts or data scientists import the Matplotlib differently, and the Matplotlib give us this submodule, they call it pyplot. Yeah, the pyplot submodule allow us to make use of all the data visualization utilities or methods. So import from matplotlib.pyplot as PLT. Yeah, this is what most of the time as. So PLT is now the module we are going to use. And in the PLT, what you should do, what do we get from PLT? Yes, and then you can see lots of methods we can use. As you can see, let's see from annotation, I've never used this, axis, yes, and that's the most common subplot. Let's get there, because sometimes you don't have to use all of the methods, but this is how we see it. Scatter, yeah, okay, x label, x limit, x scale, x ticks, y label, y limit, and y scale, y ticks, and all the necessary the necessary methods can be found like this. So when you get lost, use the dir, and dir will help you to see all the available methods there. Yeah, great. Yeah, now let's start visualizing data. When visualizing data, usually we may have like X and Y values. So we may say data, our data, maybe I can start from X. I may have two datas. That means maybe 2 and 5. Yeah, this is a point. And y is equal to maybe maybe I can say 4 and 10. Then actually this PLT dot plot give us a line graph. So X as in independent value and y dependent value. And then I want to see the marker. The marker we want to be just O, and let's see how it looks like. As you can see, the points actually 2, 4, 2, 4, and 5, 10, 5, 10. And then the marker is actually O. I mean, like circle. You can change the marker different. It could be X, now, or it could be a diamond, like in B, or it could be H. Sorry. Yeah, like hexagon. Yeah, it's hard. Then maybe NC size. Is that tuning? Wait, marker size. I forgot marker size. Ability. Sometimes, if you don't remember the other, yeah, have you seen this size? Even actually, I have my. No, is it? No. Yeah, so I think I have also already something which I've been running. So I want to use that as in a means whenever I get lost, I can make use of my cheat sheet. Yeah. Okay. Actually, the size MS, not MS. Yeah, have you seen? Now you can use the size. It's a hexagon actually. H refers to hexagon. It could be also lowercase. Oh yeah, but by default, if you don't give a marker, it will be a line. Okay, it's a line between 2 points. Have you seen? It's a line between 2 points. Oh yeah. Yeah, but how about if we had maybe 2 and 3, and maybe the value all of a sudden, maybe this one could be like it could be 1, and let's have a kind of a strange kind of a line. Yeah, maybe even we can have another point. We have 5. And then 6, for 6, even we can have also another point like 2, and we can have such a line. But as you can see, to avoid this, we have to say plt.show. Show means just draw. Now we start actually making line graph. So let's call this line graph. Yeah, it's good to make it like this. So if we notice properly, what we have is actually the X value as in list, and then the Y value as in list. And then this takes X as in independent value, Y as dependent value, and then the canvas has been drawn by this PLT. The PLT just give us the canvas. Canvas means this area. Is it clear, guys?
Yep.
So what are these? The markers, actually markers. We've been putting these markers. The markers could be as in O, or it could be a star, or anything. Okay, have you seen now? But actually, I was expecting, yeah. How if we actually explicit this marker, instead of just a scatter plot, it will be like this, a line with a marker, as you can see. So it gives us an emphasis, or it could be just this O. Yeah, I think where to get the marker, I will show you this, the markers. What are the markers actually? I prepared a note somewhere. I'm just looking for the markers, the possible markers. I thought I put them. Yeah, here we have Matplotlib markers. We can use the dot, comma, or OV and this. So you don't have to remember. Yeah, it just use this cheat sheet, and then I will prepare a notebook I prepared already actually for that, and then you make use of this. List of markers can be found here. Great. Yeah, the power of this Jupyter notebook, you can leave comments, notes like this. Yeah, but the power of actually this NumPy, I can just generate any number, like instead of like this, I can say np.range, yeah? And I may just create, but I think it's not a good idea to destroy what I have. It's better to create a separate cell. Yes, so now we learn actually graphs, and even it's better if I just take the marker, maybe I could just copy and take the marker separately. With this is without marker, but you can just markers, line markers. Now we have a different markers. And even to have a different markers, for instance, I can say PLT XY, if I multiply this with some number 0.1, and I can change this marker X Y, multiple sequence by, and yes, now why, who can tell me the problem I made?
It's a list, not
yes,
not really. Yeah.
Thank you so much. That's the power of. So what I should do, np dot array, and then pass y, and then now it should num. Oh, have you seen the problem is we didn't import numpy. So with here, I have to import numpy as np. Now, as you can see, I have this because I made. Now let's also duplicate another value. Maybe we can call this one D, like in a diamond, and maybe we can change this value to 5. And then it creates, have you seen it creates? And you remember that we can use ms for the size, and if we give it like 20, ms means marker size. Oh yes, yeah, something really, really big. And then again, let's create another. We can maybe multiply this just by 5. And instead of D, let's change it to star. And this will remain 20. And as you can see, we have a star, but actually we can change the color of the star to, we call it M marker face color. And I can change it to yellow. Yeah, but as you can see, the border is still red. So we can change it marker age color should be also yellow. And now we have a star. So this plot method actually takes quite a lot of parameters. Yeah. Imagine that it takes quite a lot of parameters. And even you can change also the line widths and something like that. We'll come to that. But even I think before this, we should have just done line widths. I just want to show you here line widths. And I have to just change. And if you line widths, and we just add the parameter line widths, and then if we just put 3, and let's see the difference. Yeah, but just to see it really properly, let's just give it 10. Yeah, that is line widths. Maybe even we don't need this for the time being, and I think we don't also need this for the time being. How about if we just see also line style? Line style. We can just, I have to create additional cell and put this. Actually, the width, I can keep it like that, and line style. It could be like this, for instance, broken. Yeah, but this could be changed to dashed actually, or dotted, something like that, or dashed. Yeah, maybe I think for you to, again, what I can do, I can just to create a different value again. By default, it's a solid. Let's leave this one. And then I can multiply this to multiply numpy array and then y, okay? 0.5, for instance, and this is dashed. Let's see. Yes, as you can see, but we can change the next one also, np, but I think instead of changing this many times, I can change this here, numpy.array, and I can just change the multiply the y, and our code will be much cleaner, right? Oh yeah, where did I destroy my code? Show me, guys. Okay.
Line 6.
9.6 extra comment over there. Yes. Oh, look at that.
Y is missing out line 6. Y is missing on line 6.
Okay.
Second argument.
Yes. Yes. Now dashed, so dotted, and this will be, we can multiply this by 0.25. Yeah, so and we can again create another. But as you can see, this 10 is really too much. By the way, I don't like really not having space when I am coding. So I really like to have spaces and do the same. That's actually, at least Python developers do not do much of the spacing. I'm from JavaScript, so I prefer making it clean. Okay, so let me just add 5. I mean, change this to 5. Just change it to 5, and it will be. Oh, it's still. Yes, and now I think another part would be I can change this by 0.75 or something. Well, why is that extra? And dash dotted, something like that. Dash dotted or dotted dash. Okay, what you should do actually, Matplotlib line style. So it should take us there again. Have you seen the different line styles? It could be something like this or like this. So if I give this there in the style, yeah, these are the common. It could be given as like this or a name. For some reason, they don't have here the name. And I think even sometimes it could be passed as in like this. Let's try this one. I will show you. Oh, where is it? Style. What's wrong? Maybe it's because of this line. Okay. Unrecognized line styles. Okay, I don't know. But it should, for instance, let me apply for just for this. No, it was recognized. What is the value? Just to be sure, let's give it a color. If I give it a color, let's see, the color is green. It was not recognized actually. How about this? Now it's recognized dash because then this is not recognized for some reason. Yeah, the different version is not recognized. So we can give it as a name. For instance, let's also check this one. Yeah, that means actually somehow similar to the dotted one.
Well, excuse me.
Yes.
I don't think maybe line 3 is really working for that line 10. Because if you remove that line 3, it's still supposed to work.
Line 3?
Yeah.
Yeah, so because I am not using it, I'm not using line 3 anymore. Because, let me show you. I line style styles, right? So this means actually it will give this different style for my lines. That's my expectation. So let's see. And if you read all the way down, unrecognized line styles. Maybe it's because of the first one. Let's change the first one. And maybe again like that.
Can you really give an array?
Okay, let me see.
Because it's a for loop.
Yeah.
And
it's a for loop, yeah. So let's see how it was implemented here. Line, yes, because it was a for loop, yeah, we can't. So it was impossible for that. So we can't give it. Actually, yeah, and at the same time, even this one is not also, this is not also supported kind of, wait, I have to remove this. We don't need it here because we need it to be solid by default. Yeah, as you can see, this one, the green line, it's, yeah, actually, yes. This means solid.
The gray one is actually continuous line. So
yes.
it's not test to that line. Yeah.
Yes. So actually, we can represent the line style. This means solid. Dashed. And where are the others? This is solid, dashed. Let me see that one, the conversion of that. I think this is dashed dotted. Yeah, this is dashed dotted. Dash dotted. And then we have another, this one, the colon. Let's see the colon. The colon is again, as you can see, it's dotted. So we can use either the name or the symbol. Yeah, so we don't have to exhaust the time just with the line styles. But as you can see, you can use just as in solid. Solid is just by default, it's a solid line. You don't have to even give it, yeah? And then dashed, dotted, and dashed dotted, actually, I can say. Dotted dash, I don't know what was the name. Dash dot, dash dot. Yeah, dash dot, it's not dash dotted, but dashed, dotted, dash dot. But here you can add the line with the line style, but it's by default, it's a solid. You don't have to write solid since it's just where are these colors coming? It's by default, randomly, it's giving them this. Yeah, so the first color, the solid one, this color, as you can see, it has some kind of this. The default color is this kind of blue, ocean blue color is the default all the time. So, and for this one, I gave it, but if I remove it, will be some random color. Okay. As you can see now, it's just getting some color. Even it's not actually a random color. I don't know how it assigned the colors. If it was random color, it should come with a different color whenever I run it now and then. But it just gives some sequence of colors. Yeah. But we can change the color by giving colors. So now let's talk about line colors, okay? Line colors. Yeah, for instance, the color for this one, let's write, by default it was blue, but we can change the color to color, and we can say green like this. Yeah, but this actually it could be just a short green, or you can write like this green, or you can write it as hexa color. I think the hexa for green is FF0, I think, hash FF0000, that's green, right? Oh, that's red actually, RGB. Okay, so sorry, this is FF here. Okay, anyway, then what can you give name the color? Full or abbreviation like green as in Jew, or green, the word itself, or hexa color. Hexa means this color. Okay, but now for instance we can just say green, and we can give this one blue. And we can give this one maybe yellow. I didn't see. There's blue and by the way, this 0.5 is a bit somehow weird, so I have to multiply just at least by 1, and it will be yes. Now the yellow one is this one. Okay, then if you want to give some color for this, and you can give it maybe whatever, black or what color? Pink. Yes, and it's pink or red, something like that. So you can decide whatever color you want to give. Yeah. So is it clear so far?
Yep.
Do you have any?
Yep.
Yeah. So now line markers, we have seen this, the line markers, and we saw different line markers. For instance, this one, this still, it's so small. We can just change the marker to 20 and it will be a circle, as you can see. And yes, I want, and we saw that marker face color could be changed, and let's make it red. Yeah. And now, and if we want to also change this, the border of the circle or the edge, so marker, edge, color, and red, and then it will be nice visualization. Okay, it looks funny here, or some kind of a decoration. Okay, yeah, so far so good. What did we cover? Let me check, because we don't want to miss. Yeah, so these markers could be anything, and we have seen that the markers can be found here, the different markers. Yeah, so you don't have to remember by heart. That's the now we have seen that we've been drawing this a couple of times. Just I want to 100%. As you can see, we have X and Y, and we just and we don't want to need any kind of yes. As you can see, the X value, this one, the horizontal value, the Y value, the vertical value from 2 to 4. Yeah, actually, it's just, it goes from 0 to 10. As you can see, it has been sorted. This has been sorted, and it's just 0 to 10. And again, 2 to 6, and as you can see, 0 to kind of 6, something like that. It has been, and the point, to see the point again, you can see a marker, and you can just say something, and we can see the markers. Now, sometimes, how about if you don't have the X value, just if you pass the Y value, just if, what do you expect? Actually, if you just pass one value, that will be considered as a Y value, and the X value will be the size of the size of the Y value. How many elements do we have here? 4. So it goes from 0 to 4, as you can see. Yeah. 0 to, I mean 0. Yeah, 0 to 4. So the index of this 0 to 4. But most of the time we give value. So this X value, for instance, it can be also changed to names. X is for X, and this is for Y, and this is for XYW, and this way for Z. So this shouldn't be what is this? A number. It could be some other parameters. I was expecting, yeah, I didn't pass the X value, sorry, X. Now, as you can see, X, Y, W, Z, yeah? So if you remember when we visualize the cat's value, the country, or maybe the breed, different things. It could be a year, or name of a person, or country, or whatsoever. Okay. Now, so the default value of the x-axis, if we don't pass the x-axis, it will be the size of the y-axis from 0 to the last index. That's the point. And I have this value, the point I have created before you come. This is just some random value. If you say P, T, plot, and XY, and it just gives you some kind of, it goes up, and some, and just go down. And the value from -3 to 6, yeah, -3 up to 6, and the Y value from -2 to 4, the maximum is 4, as you can see. And we have to remember PLT.show, something like this. Yeah, and it could be some kind of relation, some kind of boiling point or temperature, whatever, I don't know. I just come up with this data and visualize this. So we can't say anything about that. And another thing, actually, we've been doing this. For instance, you can have X and then NP, a range. Okay, what's the value of this? How many elements are you expecting from this?
10.
10. From 0 to 10.
Yeah.
I think it will be 11.
Yeah. From 0 to 10, which is 11. Yeah.
Yes. Okay. So let's see what values we get. As you can see, 0 to 10, and if we want to know, print the length of the X we have. And then actually, how about if I want to draw Y is equal to 2 times X. So this is actually a kind of a value. Let's see, print Y. Yeah, so this is a linear equation. PLT dot plot XY. Yeah, a linear equation, so nice. And actually, as you can see, it starts from 0 to 10. It doesn't include, right? And you can also add the points. Now you are good at marking, marker, and you can just do X or whatsoever, X or star, anything you want. Yeah, these are the points. And we forgot to add the PLT.show. Yeah, but this shows only the negative, only the positive side, right? We can start actually from -11 to 12, because in both sides, yeah. Now, as you can see, I have both from -11. From -11 to positive 11 here. And also the value is actually, so if it's -11, I should get -22. Yeah, this is -22. And if it is, I should get 22. Yeah, great. And we can do the same for other, for instance, if you want to change, I think if you want to change this, if you multiply this, it will be the other, this is, as you can see, the other side, because it's a negative. So this is increment and this is decrement. And we can also change this to a kind of a parabola. So if I change this x square, so it will be a quadratic equation. Yeah, quadratic. Even you can add something -8, then it will cross, as you can see now, -8. So the minimum value for this, when this is 0, -8 is the minimum value. So you may see -8. So I think it goes up to here. So somewhere around here will be -8. Yeah. Great. Yeah. And if we want to just to do the same.
Excuse me.
Yeah.
Is there any possibility to set a class interval between X and Y?
Class interval?
Yeah.
What is class interval?
Okay, for example, if you look at the diagram, the latest one is from 0 to 20. No, go down again. Yeah, from that one, -10, -5. Then 0, 20. Is it possible to have 0, 10, 10, 10, 10 interval instead of 20, 20 interval? Do you understand? Or as we explain again?
The interval. I didn't get to what you meant.
Okay, if you look at the last graph,
yeah.
If you look at the interval between the number y-axis and x-axis, if you look at the interval from a y-axis, the interval is 20, 20.
Yes. Yeah.
And then,
yeah, got you.
Yeah.
Yes.
Is it possible to make
yes,
the interval to be like 10, 10 instead of 20, 20?
Yeah.
In this subject, yeah.
Yes, it's possible. Yes, it's possible to change the intervals. Yes. Okay, that would be changed by x tick. Okay, x tick lt. Yes, it's possible. We'll come to that later. Before we.
Okay.
Yes,
okay.
But it's possible. You can change these ticks, but we will come down later. Okay, so wait, where was I? Now I want to add actually. We have covered the line widths and something I line style, by the way, I was just doing this line style part, and it will be also line colors, line styles. This one is one fancy what we have covered here, and this is also one of the colors I made, so you may try to also recognize how it was made. It will help you. So I'm just adding it here as a note for you for revision. So how to create this and this, and at the same time you will have a chance to see. Yeah, we're having good notes here. And even at the same time, I have also created another example for the same thing. So I can just leave it here. But here we didn't cover about line colors, right? Yes, but it's okay. Since we have now it. What am I going to add here now? Yeah, so actually one of the point I want to talk about is here now is labels. If a graph doesn't have a label, it's just hard to understand sometimes. And I have a very good example. I just collected this data from somewhere, some note. Mathematics is fun, a website, and I make this data. The temperature is this, as you can see, and the cells of ice cream. I may just add this in cells of ice cream per day, I think. I have to just comment this out. So this is, we have this as X value, and we have this as a Y value. Then penalty dot scatter, we can make a line, but if you just make a line, it's not a very good point. I can just change it to a line and it will show you line, and not line, actually plot, and then you will have, this is not a very good visualization. It's a very good thing, scattered. Yeah. So we can see that there is some correlation or relation between the cell of ice cream and the temperature. Yeah, when the temperature is rising, lots of people buy ice cream. So so we can use X label to give a label for this, Y label for this, and the title for this. Yeah, so we can, and then I think the next step is how we save. Saving this, saving graph. Yeah, because saving is also important, and you may have here again, because I am just using a different cell, and how we save it actually, plt.save figure, and you can just give it the path name, but I don't want to go anywhere, just temperature, ice cream cell image. Yeah, now if you go, if we go here, I think there should be an image this created, but for some reason it doesn't have the labels. Why? It's strange. Save figure. Sure. Yeah, it's just the Visual Studio didn't show the labels properly, but it has. Okay, great. It was strange, yeah, but it doesn't show that. Okay, let me just get closer and try to look at. Because the background is also black there. I can see it now. Yes, temperature here. Yeah, do you see it? I don't know, but I can see temperature here.
Yeah.
Yeah.
So it's the black background. Okay, so let's move on. What didn't we cover so far? But before we move on, now we should have a 15 minutes break, guys. I have to give you a 15 minutes break, and I will see you after 15 minutes. Yeah. Welcome back. There is one NumPy method I think we forgot to cover in the NumPy. I'm not sure, but this NumPy dot line space. And this line space actually takes the starting number. Let me check the line space NumPy. It's good also to know how to read a documentation. As you can see, it has a starting number, stop, the size, and point. It could be true or false. And what is this? The red step false data type. We can also decide the data type and the axis. So for each parameters, we can also read here, start, the starting value of the sequence, stop, and the end value of the sequence, unless endpoint is set to false. If we just endpoint turn to false, then what does, let's see. Then as you can see, I can start from 0, and the endpoint is going to be 10. And is that how it works? Yeah, and then the total size. How many numbers do I want? Maybe I want, maybe it could be 100. And then I can store this at X. Then print X. As you can see, I was looking for a value from 0 to 10. And total value is actually 100. So 0.00 something, as you can see, 0.01 up to. And if I change this again, you will have 1000. So this can, because the importance of this, if you want to make, for instance, X is equal to y is equal to x square, right? And if you use in range, a range up to some kind of 101, so this actually just gives you only integers. Yeah, integers, and the total number, this one is actually 101. And plt.x plot xy, and it may give you something, yeah, like this. Of course, you can also start in a minus 101, the other side, the negative side too. And if you want to see the marker, and you can just see. Yeah, actually, this is good enough. Yeah, we have good enough points. Yeah, have you seen the points? Let me just maybe change to a dot. If I make this a bit, for instance, 10, maybe 11. Yes, we have something like this. The data points are small, but if we change these actually to line space, and the starting is minus 11, and the ending is 12, 11, it's true, and total what I want to get is actually maybe 100 points, data points. Have you seen now? I make 100. I can even change to 1000 data points. Now, as you can see, there are quite a lot, and you don't see anymore the points. Have you seen?
Sorry, what is the difference between the line space and the random?
Random. Okay.
In this aspect, what is the difference between line space and the random number? Yeah, random the number, yeah. Because
yes.
it looked like the same thing for me.
Yeah. Okay, let me show you. For instance, X and the P dot line space. And if you say, sorry, space, and if you want 0 to 10, and if you want 10 number already, because actually 11. What do you expect from X? As you can see, 0 to, because I want from 0 to 10, I want 11. You can also decide the data type, int. Have you noticed the result here?
Yeah.
But if I am interested to get 100, do you think it's possible with int? Because int is not possible to get it like that. But for some reason, it gave me such a kind of a data. 0. I was not expecting this because of
it gave a number like 0, 10 number, 1, 10 number, 2, 10 number, 3, 10 number, like that.
Yeah, the reason why, because we crippled it, because it's impossible to get integers in a range of this to this. It should be just, if you remove this, or if we change to a float, you will see the difference. Now, actually, I'm getting values from 0 to 10. Have you seen? By a small increment. Then the step is small now. By the way, we can add the step size. Okay, now, for instance, I may want to add 0 to, okay, let's see again. I want to see the step. Where is this? Yeah, NumPy. Step false. Yeah, step float optional. Yeah, we can even use step. Let's see the step, for instance, by adding just, I want to get 10 number, maybe 15 number, and the step could be 0.5. I'm not sure if it's the step is 0.5. We have 0, but as you can see, it's not 0.5.
No.
Yes, but most of the time we just use this to produce numbers of smaller steps. Just to reduce the steps, we can change, you change 20 and the step size reduce. And if you just increase also 100, yeah, so it's not random, but it's a sequence of numbers, a sequence of floating numbers or integers. But random, numpy.random, this one actually just, yeah, numpy.random.random actually. Yeah, numpy.random.random, this produce something like this. And if you pass a value, it produces an array, 5 of them, as you can see. Yeah. But this gives you all the time 0.0 to 0.99. Or if you go num.random.randint, this is actually produce 0 to 10, as you can, yeah. And actually you can change the size, maybe 5. 0 to 10, I want to produce 5 of them. Even you can change actually the dimension, if you remember, 3 by 5, 3 rows and 5 columns.
Yeah.
3 rows and 5 columns. Yeah, this is the difference. And again, I think we can do also here the same. We can also change the dimension, the size. And if we say, 2, got multiple values for okay, then I think
it should be something like 5,2 or 2,5, something like that.
yes, 5, 2, something like this. Yeah, we have to pass it as in a tuple. A tuple, 5 means 5 rows and 2 columns, and you can change this if you want to 5 by 5, and you can just get yeah, it's too much. Let's just make it to 3 and it's easy to see. Yep, this is the difference. And this one is really important sometimes when you need sequence of numbers. Even you can produce. Okay, I have a question. How many numbers do you have between 0 and 1?
Infinite.
Infinite.
Yes. So we can produce many numbers between 0 and 1. Or you can also go this, -1 and 1. And if you just generate now, we got something like this. Sometimes, for instance, the value of this sign, it go -1 and 1, right? The value of sign, if you remember, this, I can go to here, visualization. So the value of, for some reason, yeah, it has been multiplied by something, but as you can see, this value has some upper limit and a lower limit. So sometimes we may want to produce the numbers of some range, and it helps us. Oh, okay. So now let's just move on to the next part of the lesson. Okay, then there is subplots. Subplots. What is subplots? Because sometimes we want to draw in, like, for instance, if you remember this one, I draw how many? 1, 2, 3, 4. 4 lines on the same canvas, right? Yeah, I have one canvas and I have, how many lines are there for? 1, 2, 3, 4, 4. But instead, how about just putting them in a different plot? So we use this plt.subplot, and then actually it takes 3 arguments: the row, the column, the row, the column, and that specific plot, the name of the plot. Okay, so what does that mean? So let me just make something. 2 means actually 2 by 2 column, and the first plot or the first graph. So it gave me a canvas. As you can see, this gave me a canvas, this canvas. Okay. And maybe just by default, it gave me 1 by 1 canvas. And how about if I change this to also here, I can just plot it here. 2. Yeah, as you can see, I told you that it's 2 by 2 means 2 rows and 2 columns. And now I want to third this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. So this is the Yes, now let's do at the first quadrant. Before we move on, did you understand what this means? Like when I say 2 by 2 means 2 rows, 1, 2, 2 columns, 1, 2. What did this represent? The quadrant at the first, the second, the third, and fourth. Is it clear?
Yeah, so you can plot multiple graphs into the same picture, or kind of different graphs.
Yes. Then what we can do here, plt.plot, but we don't have data yet. Now let's see, x is equal to np.array. We may have just 1, maybe we may have minus, yeah, I think range is good. Or a line space is good, line space, and we can have starting from minus 11, and we want to go up to 11, and now I want to generate about 100 points, yeah. And then the value of y, actually I will decide the value of y later. Then I can say plt.plot x to the value of y will be x times x, and then I just plot it. As you can see, I have this plot. Yeah. Okay, then I can just do the same here. If you go plt.plot x remain the same, but minus 2 times x, and the color will be red just to make it different. Let's see. And then we have this one. Okay. And then I can just create a quadratic equation over here. plot x square. It's already quadratic. You can have the intercept if you want, the y-intercept, but you don't have to. And color green. And even you can put a marker if you want, but let's just see. Yes, but we didn't have this finally, the reality show. Okay, now we may have some kind of a graph, a different graph over here. Okay, maybe we can say plt.plot x and x the power of 3. Yeah, as you can see, this is a polynomial graph. As you can see, it has 2 turning points, 1, 2, and the turning point plus 1 give us the degree. So it's a degree 3 polynomial. So as you can see, we managed to do something like this. So to visualize it, but we can also change the direction by just, for instance, instead of this, we can make it to in 1, like.
Sorry, excuse me. Yeah, hello?
Yes.
Yeah, is it possible to have this also in the Visual Code, to have something like this?
Yes.
Okay, it's possible. Okay, good.
Yeah, but as I told you, for instance, Visual Studio, if you remember, whenever you just run the Visual Studio, it displays the graph, and you have to close the graph again. It's not a very what is called a smooth experience or a fun experience, especially when it comes to the graph. Yeah, you remember, you have to close the graph now and then, but here it's somehow natural way, but it's possible to do. And even sometimes you most probably need to use the Visual Studio Code, for instance, if you have a plan to deploy it or something. Yeah. Okay. Shall we move on? Now, by the way,
Yes.
you can even just have additional, so you can make it 3 columns or 4 columns. This is just an example. So to change the number of the columns, just change this value. To change the rows, the first value. Yeah. Is it clear, guys?
Yep.
And as I told you, to change from a scatter, what is this? From line to scatter is just straightforward. As you can see now, since it doesn't make sense here, making this, because what's the point of visualization? The point of visualization is actually to make the data easy to be read or to help our to recognize, yeah. So if we change this to a line, actually, it's not, no, sorry, plot. I usually make a mistake, plot. So it's weird, yeah. So it's really hard to interpret this. So scatter is much better, yeah. Right. Now let's move on to a bar graph. I know you love bar graph. Bar graph. And let's change that. Okay, good. Bar graph is one way of visualizing data. For instance, I have just created data. But I think something I didn't show you here also maybe before we move on to the next part, the grid actually. The grid part is something I want to show you. Now we can apply grid in any of the values. Maybe I can apply to this one. Okay, for instance, you can just add adding grid to a graph, because the grid sometimes help us to visualize it. Maybe I can just copy this and okay. And then at the same time, what I do is actually lt.grid. Yeah, as you can see, just the grid method created X grid and a Y grid. So it's easy to see the values, yeah? Yeah, this is almost 14 and 200. And this is almost 16 and 200 something, 320 or something, yeah? It allows us. But maybe sometimes you may not want to have both grids. You may want to have only the X grid or the Y grid. And then if that's the case, actually, you can say X is equal to, axis is equal to just X. Now we have only the X-axis. And it's up to you also to use color. Color, maybe we can say not like that. Yeah, actually it's color. Let me try this green. Yeah, green, as you can see. And again, line style. Maybe we can go dashed. As you can see, we change the grid line to a different, like dashed or whatsoever. And even we can change the opacity or the transparency we have this alpha, which is going to be 0. It goes from 1 to 0 to 1. Let's give it 0.75 and it will be transparent. Oh, I think it didn't change much for some reason. Did I make? Yeah, let me try. Alpha, maybe let's change this to 1 and see if there's a difference. Yeah, there's a difference actually at 0.01. Let's see the transparency. Yeah, because 0.01 is too small, and I can see actually the transparency now. You can also evaluate your eyes. If you manage to see some broken lines, I can see it, but it's really, really small. Let's change it to 5 for such. Yeah, now it's coming. Have you seen it? Yeah. Okay, but 1.5, definitely you will see it. So it's really working. This is the transparency, but most of the time, maybe just 4.5 or something. Yes, so we can add this kind of transparency, and if we remove this the x-axis, actually you will have grid in both directions. Yep, that's all about grid, guys. So this grid will apply for all kind of graphs, and it's not only for line or scatter or bar graph. So we don't have to repeat the same thing all over again when we go to the other section. Let's just dive into a bar graph. Okay, I have this data, as you can see, data just I created 20, 50, 60, 80, 10, whatsoever. Then you may have just axis, the y-axis. I have also the y-axis I have created. Just 1, 2, 3, 4, 5. So just a number. Then TLT, instead of plot or scatter, bar, X, and data. The data is actually is the Y. So I can call it data. Oh yeah, so you got this. Yeah. Then it's good to say TLT show, and you don't have that object. And then again, you can add alpha, what's this? Alpha is equal to 0.75. If it's really, just to make this a bit lighter, you can use different alpha. And it gave us actually this, the original color or the default color. So can we pass a color? Yes, color is equal to coral. For instance, I like coral. Why? Yeah, actually here, color is not C, it's just like this. Yeah, that's inconsistency when it comes to, yeah, it's inconsistent. It would have been much better if, but the good thing in here, the color thing, it takes also different colors, you can say, arrays. Like the first one I want to be red, and the second one I want to be blue, and the third one I want to be a yellow, and 5, right? And a green, and now let's make 2 coral, for instance. And then if I just pass the colors, I have a different color. It follows the sequence. It just map. This will be mapped to this, like this. But I think it's a bit quick. We will do this step by step later, because now just I want to show you just why still. Okay, colors, I can just give without a color, and let this have, and we don't have to have this, just simple bar graph. Yeah, you love simple bar graph, 1, 2, 3, 4, and I can just have an app creating a simple bar graph. Someone joined us and left. Okay, Okay, now let's add a color, adding color to bar graph, because guys, the reason why I'm just adding note for you, it will be easy to revise and also documentation for later use. You have to. Then actually we can repeat this. And we have this data X, Y, and now we can add a color and do maybe coral would be good color for us, yeah, for the time being. So, and then in the second section, actually we may create and again, it's the same as adding opacity. If we add opacity, then what we can do actually alpha here. Alpha, and you can just give 0.75 and it will be less bright. And let's do this. We don't need this part of the code over here. And then now adding multiple colors. Adding multiple colors. As you can see, I have to change this to markdown and change it to something else. As you can see, you have colors as in array and data, and then you just run. The color is not anymore one color. Instead, you pass the colors array, and then you will have different colors. Yeah. Okay, good. Maybe, for instance, if you want to give name instead of 1, 2, 3, 4, named, for instance, this value, we can change it to something different, some value. We don't know this, but we can give it a name. For instance, the red one would be some technology. It could be HTML or something, or maybe a country or something. But since I have no idea what I call it, just A, then B, because it's a neutral kind of label, C, D, and E for the time being. So as you can see, we have this label, and now we can say adding a name to x-axis value or whatever. I don't know what name to give it, but for it makes, what am I doing over there? It's not a code, it's a markdown. Okay, thank you. And this is supposed to be a code. Great. And then I think it's good to add a label. Adding a label, it's the same as to bar graph. Adding label is the same as a line graph or scatter plot. Okay, so let's just add this over here. Yes, then where is it going to be? We can just here LT X, we can say label, and we call it X label. Yeah, so we should have X label, and we have to have the Y label. You just change this one, and I just change this to also Y. You have a Y label over here, and let's have the title of the graph itself. And we don't know what this is about. We can just X versus Y versus is something versus Y, whatever. But why? I think I didn't change this to a title. And then we have this. Yeah. Can we have a grid for this? Yes. You can just adding, we can check this. Adding grid to bar graph. But once if you get the concept how this plot works, it's so easy, I think. Let's add, then you can just say lt grid. You just invoke the grid method and it gives you the color of the grid is actually, yeah, it's a default color. So you may say color, maybe green. Yeah, yes, it's green. And you can change the opacity by using alpha, maybe 0.45, and it will be less. And even you can change the line style, to be dotted, yeah, because I forgot. Yes, it's dotted. So as you can see, or dotted means the same as this, or no. Okay. It's a bit different. This one is dashed. How about? Yeah, this is dotted actually. This is dotted, and this is solid, and this is dashed. Yeah. Yeah, it's a bit different. So late, but you can use also just dotted if you want. Okay, more widths. If you want the widths, you can also add the line widths, but I think that's enough for us. If you change 5, it will be really big. Oh yeah, but this is not something you want, really. You just leave it, maybe just 2. And yeah, it depends, but it's good to know it's there. Okay, thanks. At least I don't like it. Okay. So for, yeah, we saw just the 1 bar graph, and I hope you understood what we've been doing. But sometimes our data is not just something, you know, we have something just like this kind of data. We may have different data. We may want to compare different things at the same time. Yeah. Yes. For that, I just prepared some dummy data for you, multiple bar graphs. So I called it multiple bar graphs. And how I made it, I will show you. It's better if I just copy the code first and read the code for you. Maybe I will show you this. I think I want to ask you, what do you expect from this data 1? Maybe I just want to show you a data 1 and random 0 to 100. It's an integer and size 5. So I'm expecting just 5 numbers. Let's see, print data 1. 5 numbers. Is it clear? Are you okay with data 1?
Yeah.
Yeah.
Okay, great. And we do the same for just, I did 3 times because I want to have, because this is random, so the data you get is different. So are you okay with all those 3 datas? Yeah?
It's okay.
Okay, great. Then actually we have this, the y value, and we don't care for the x value because so far we've been using just 1 to 3 or A, B, C, D, E, right? So then for x, we can just use some x value. I can just say x is equal to this because I have 5 values, 1, 2, 3, 4, 5. The x and the y should match, okay? Should match. If you have 5, You should have 5 for that. Then what we should do actually, PLT dot bar, and then X data 1. And then I want the widths, it takes the widths. I want the widths to be some kind of a widths. I can decide, I can just give the widths here. The widths of the bin, we call this bins or bar. Okay, I will show you. And then I want it to be for the time being 0.25. And I can pass widths. And there is widths.
You've got extra parentheses on line 4.
Line 4, yes. Thank you. Yeah, as you can see, I have these guys in let's just penalty dot show. Yeah, nice guys. So I have 1, 2, 3, 4, 5. The reason why I give this a small widths because I'm going to populate the rest of the spaces, but you can also check by making this bigger for 5. Have you seen it's getting bigger, right? And oh, and why for 8, 5. Guys, why is it changing the data? Why? The previous data was not like this. I just only changed the widths. Why I see such kind of bar graph?
Because we are random the number.
Great, yes, because it's random. Yes, so every time you will see different. That's the beauty. Now it's almost, as you can see, uniform. But now just let me get this back. And as you can see, then we will have. So how am I going to add the second bar graph? So you penalty dot bar, and then X will remain the same X, but actually instead of like this, X should be an NumPy. NumPy dot array, because it's hard to add, multiply on this NumPy array. Yeah. Then I want to add some value on this part, some widths. We can just add a widths on the value of the X. And then data 2. And then widths is equal to just the same widths. Yeah. As you can see now, we added this amount, then we will have some. If you don't have this, what will happen if I don't add it, the weights? It will be overlapped. Have you seen just a kind of overlapped? So that's why we need adding that weights. And then there will be, yes. Now I have, so it moved some amount of distance, the same distance. But how about if there was more instead of 0.25? How about if it was 0.35? I will show you. There will be a space, and we don't want that to happen. We just only to come next to it. So just wait. Okay, now we want to add the third. Okay. Now I want to add the third value. Let's copy. How much distance do we have to come here? Here, this. So 0.25, 0.25, right? And then that means actually what we should do times 2 and data 3, and the widths remain the same. Yeah, as you can see now, I got something like this. Of course, since because you are using random, But for a demonstration purpose, I just created a random. But in real life, for instance, you can do for the caps, because we generated quite a lot of different kind of data over there. I think if I go, when was the date? So I think it seems even before. I don't know. Do we have any generated graph? Maybe here. Yeah. Yeah, for instance, weights in kilogram. And also you can also compare with the year. Yeah, so the year can come. So you may, yeah, there will be lots of things if you visualize, for instance, lifespan and weight together. Yeah, there might be some correlation. Lighter cats might live longer than heavier, but I don't know. But we can get some insight by visualizing those parameters together. Yeah. Okay. Wait. Then I created this color, because you get this by default, but we can pass the color, for instance, this. And I think I want to call it colors instead of just color. And you can pass it somewhere. For instance, you can pass it in the last color and colors. Now you got something different, but the default color remained the same. I don't know why. I think some why. To apply it. Or just do I have to apply to all of them? I'm not sure for this one. No.
Maybe you can give only one color per one bar plot.
Yeah, yes, that's possible, but yeah, yes, but there's a way to give just arrays, yeah, as we did here. Yeah, as you can see here, for instance. I don't know why here, but as Miko said, let's do for the time being. And you will figure out, guys, yes. If teacher is lazy to figure out this, then you will have extra work to check this out. Okay, then copy and do this, as he said, manually. Manual work is something I don't like and appreciate, to be honest, nowadays. I prefer to automate something. Yes, some kind of a color. You got, yes. So we have 3 data. But yeah, do you have any question?
Yeah, Asabene, can I ask a question about this plotting? So you have plotted multiple graphs on this page. So is this plot like a global object, and then this plot.show kind of ends the plot, or what actually separates the different graphs?
Yeah.
Do you understand what I'm asking?
Yes, it's a global actually. It's a global. So sometimes for a teaching purpose like this, it may have a problem because we have a tendency just to add lots of things now and then. So we are affecting the whole thing. Yeah. So it doesn't end by just PLT.show, but Okay, let me just, but it will be overridden every time. For instance, here we have the bar graphs. No, it's a group, but your question is like the show. Let me just see what I get without a show. Actually, just the penalty don't show. It's just to get the clean view of the graph. It's a global. Penalty is global. Once, if you remember, we declared at the top, but every time I think we can also have a chance to override the attributes. For instance, you have said here penalty.bar, right? So whenever we declare penalty.bar, so we are overriding what we had at the top. So we are creating a new object to the, we are creating a new attribute to the object. Are you satisfied with my answer?
Yeah, are there some of the values, so are some of the values like residual now from the earlier invocations, or are we always like overwriting the values?
If you don't override, it will be, if you don't override there, you will have a residue.
Okay.
Yes.
Yeah. Thanks.
Yeah, I don't know if other people understand. Yes, there's a high chance of having a residue, guys. Maybe, yes, there's high chance of, and you should be aware of that. So what you can do, maybe even it's hard to copy some part, I mean, a copy of having a plot different, but in real life, we don't really create lots of things. This is for a teaching purpose, so I'm creating a different process on the same notebook. In real life also it happens, yeah. Okay, now let's move on to creating a, but I think this is really too transparent. I can change it to this. And now let's move on to stack bar graphs. So maybe what do I mean stacked bar graphs? I will show you. Stack on top of another, stacked bar graphs. And I will use the same data here because it's going to be somehow and in this case, it's so simple. We don't have to use the weeds. If you avoid the weeds, it will be stacked by itself, and you are good enough. Good. Did I delete also the data itself? Oh no.
You delete data too, yeah.
Yeah. Okay. So this is what you need. Maybe still we have to this problem. No, it's. Okay. This is okay. This is not okay. Data 1. Let me just remove the colors too, and let's see the default we get because it gives us default. Yeah, residue. Now we are suffering from a residue effect. That It's not because we have a problem, I think, but it's because of the residue. Data 1, data 2, data 3. Yep. Let me, how do we stop this residue effect? How many colors do we have? How many? Data 1, data 2, data 3. And we have data 1, data 2, data 3. And we can go to the documentation also. Stack bar graph. Yes, another way of actually avoiding this avoiding could be this we can copy this code and make use of our own. Yes, that's the beauty of this Python. You just copy a code. So now you have main means, women means, mean standard deviation. So we don't need all this, the for data. So in our first, what you should do, just check if it's running, yeah? And then the second step, what I should do, I just replace at least the 3 data with my data. So first, let's see, 5, 5. What is this also? It's 5. Great. I don't need all the 5. So then I can just replace it with data 1, data 2, and data 3. Then actually in a Matplotlib, you can say plot.subplots, and you can destructure or unpack fig and axis. The fig actually allows you also to change the layout and the size of this canvas. But for the time being, we will focus on this one, the axis. So axis.bar, and then the labels. The labels is actually the x-axis. And then we have this now. We don't have to change it, but if you want to change it, you can change it to hours, to this, to X, and then you just change this to X, X. Okay. Then the means, main means, okay, in our case, just data 1, data 2, and we can keep just the, then there is this error, because as you can see, Have you seen this dot? But we are not interested in that part now. We don't need that. And there's a label for this one. Yeah, in our case also, just let's leave it like that for the time being. Men, women. And we want also do the third one, X data 3. And we can just other bottom means and bottom mean. Yeah, we don't do this. I want it to be just displayed by default, but as you can see, we can even decide the orientation. Now let's just see what we have. Still, as you can see, I have a problem with my residue effect. Okay, let's see because we don't see what data we generate, and when we generate also. Yeah, I think the good thing here, what we should do, print data 1, data 2, and data 3. Okay, for instance, this one, it doesn't have other values, right? But why? 88. Yeah, there's some residue effect, but let me just go down. Yeah, I can just run this over here. Okay. Yeah, we have only 2 values. Don't really need the weights because the weights are adjusted. Even in this case, we don't need. Yeah, as you can see, the width is nothing to do with the, so the width is just a space. So now instead, this just divide for us. What is this? The Matplotlib divide the area into equal 5 sections. So, but if you want to limit the width of this, you can still limit at any point you want. Oh, but for some reason, okay, maybe, is it let's reduce our value maybe to 50, and if there's some change. Okay. I don't know. I couldn't fix this one, but I think you can have an understanding of how it works from this one. What you need, you will have a label, and you will have the data. In this case, for instance, if we follow this one, do you see these lines? It's the standard deviation of the value when it's marked, but if you don't have to, just do not have to have the standard deviation, that error, the standard error. So we can have also just like this normal without that. And maybe even you don't have to say bottom main means, you can just have whatever to be. I see. Actually, that's the problem I had. Yeah, this is the problem I have. So the bottom has to be actually mentioned, that whenever I don't have the bottom, as you can see, sometimes I may not have, yeah. So we may fix this also. Hours, data 1, data 2, and bottom. For instance, this one is the bottom was, I think, let me undo. Main means I can just the bottom make it data 1 or data 2. Data. Yeah, as you can see now, I managed to see all the datas. So one of the data has
remain number 4. Number 4.
Number 4?
Yeah, from the graph. It's just only 2. Oh, I see small number. Okay, 0. Yeah. Okay.
No,
it's okay.
Yeah, it's okay.
Yeah, because it's random 0. So then.
Yeah, because it starts from 0.
Yeah.
Yeah, 0, but we can limit that. So, yeah, 0. Yeah, it says number 4 is 0. I think one of the reasons we're having, actually, it could be also when it's 0, the value is also 0, because we limit it to 0. So it would be nice, for instance, if we put it 10 to, yeah, I just came up with a random value, and we can just, let's see, 100, this one, and we will have value all the time. By the way, it's inclusive. That means it's just, and yeah, now even maybe let me just remove this part. Yeah, not really. Actually, we should have this one of the data should be, yes, where was I? Yes, good. And now, for instance, this do not have a value. Maybe I think this it's maybe 0.
But that one doesn't show 0. It doesn't show 0.
Yeah, actually it doesn't go 0. Yeah, that's true. It doesn't. Now we fixed already that it doesn't go 0, and even if we go the value for that, we don't have 0 yet. We don't have 0. This should be 0 to be that. Okay, well then why? Yeah, it's something related to overriding or something I don't know exactly now, but I think you got the idea how to make this. And the other thing is actually a legend, and axis.legend, and the legend can be also moved to different position. And how to do that actually? Do you have to remember all these things by heart? No. So as you can see, I have also a problem to remember everything. Lots of people did lots of documentation. For instance, do you see this Matplotlib cheat sheet? Yes, in there. So if you go this cheat sheet, yeah, it shows you how to make a different graph. Yeah. Yeah, if you see this, it looks like a sine or cosine graph and some scatter plot, a bar graph, image show, the contour and quiver, I don't know, and the pie chart, and how to write or how to write text, and the different color maps. It's not only this, there are lots of such a kind of a cheat sheet made by people, and you don't have to have this because it's already, they already linked this with documentation of the, as you can see here. And also just you come here, an example, for instance, whenever you want to draw something, you come over here, yeah, and just copy the code. For instance, if I want to have something like this, as you can see, I just copy the code, this code, and adapt it to my purpose or my problem. Yeah, if you just put it here, first the best thing to do, just run it with the, at least it works, everything works, and then actually it's changing the data based on the data you have. Okay. Great. Now let's have a break of 10 minutes. Yeah. Welcome back, everybody. So now we will talk about histograph. Okay. Okay, histograph. I think for histograph, even last week, we were learning, where is it? I think I opened it just a while ago. I don't know where exactly. Let me check. I don't, maybe see. Yeah, I think it's here. So this NumPy allows us to generate random data. For instance, if I just take this data, a uniform distribution, so this NP.random uniform between -1 and 1 values, like just give us 1000 data. So we can draw a uniform distribution using this method. It's crazy. So I will just, I don't even remember this one. So I have just, we can see how it looks like together. So what you should do actually, plot dot hist, and you pass this data, 1000 data. 10 is the number of beans, and the density is to have some line, and then penalty dot plot beans, the number of beans, NP1 likes, and then we pass the beans, line widths 2, yeah, now we know the line widths and the color whatsoever. So let's see. And then it gives us something, a uniform kind of distribution. This red line is actually the density. If you don't have the density true, or if you just turn it to false, you will not have that. Yeah, but let's have it. And you can just change the color of that to different color if you want. But it's not the kind of distribution we may be interested. I think the normal distribution, this is a distribution I like the most, and I have a sample code, and let's see that. As you can see, normal array, normal distribution array, and normal 79 is a mean, and this is a standard deviation, and this is the sample size. Okay, mu, mean, sigma, and standard. Yeah, the mean is the mu, and sigma is the standard deviation, and this number is the size. Yeah, so if I just print this out, I will have a 10,000 number. Maybe if we can just check 10 of them. Yeah, we have 10 of them, as you can see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then if you make it 100 or 1,000 or 10,000, you just get, but I'm not going to print that all here because it's not nice. Okay, then let's do the plotting using that code. And you can get such a kind of codes from here, from the documentation. Examples. You have to select. Something like this, or this histograms. And you read. Yes. Okay, then as you can see, normal array. Yeah, this is the data, and the beans we want 50.
Sorry, from that line 3. Maybe it's better to remove 1 sigma.
This?
Yeah, remove 1 sigma there so that you're not confused.
Sigma. You mean? You mean like this?
Yeah, correct.
Yeah, now as you can see, it's good. It's good. So mu, sigma, and size. Number of observation or data, number of data points, we may say. So we have here actually this great a data point that has 79. You can change it. For instance, I want to create my student's age. Most of the time, the mean would be 28, and the variation will be about 10. And I want the data size will be, maybe I can start with 100 students. And let's see, yeah, it looks like this. But if our data is bigger, really bigger, it looks like a real distribution. Have you seen? Yeah, now I have how many? 100,000. Yes. So it looks like a normal distribution. So this is how we make use of the Matplotlib to do a different visualization. I may just also show you the pie chart. We have used pie chart already. And pie chart is, for instance, if we have a data over here, as you can see, y, PLT pi, just it gives you something like this. But you can label them. So the labels should be, for instance, I can say labels, and the labels will be labels, and we can just the labels here. We can put them, for instance, HTML and CSS and JavaScript and React. So you have to read, cannot multiply sequence by nonint of type floats. What? Labels, it should work. Three, four, 1, 2, 3, 4. Oh yeah, labels. Maybe I have to call it. Yeah, I have to pass that labels. And now something like this, and if you change the variation for instance, of course, this value I think shouldn't be more than 100. Yeah, the whole sum will be, what is this? This is 50 and this is 50. So all the sum should be 100. So if I make this for instance, yeah, it's just yeah, that's of course we can also add this explode something parameter. This actually takes a lots of parameters, explode. So, and then we'll have some kind of explosion. So the explode takes an array usually. So the array usually explode. I will show you how it looks like. Oh, and you should see 0.2, 0, 0, 0. So if you want this part to explode, then you just give some point for the HTML. Now the HTML is going to, go out a bit. Let's see how it looks like. Have you seen? Yeah, but if we are interested in the bigger part now, or maybe if we want the React to explode, we can change this to 0. At what position is React? Here. So we can make it 2.5 or whatsoever. Have you seen? Something like that. Just to make emphasis, but usually the big portion. So let's do the big portion is actually the HTML, so we can make 0.2 and the explosion happen at HTML. Okay, good enough. This is just the beginning, and this is just a very basic of data visualization, but you got the fundamental of data visualization using Matplotlib. Is Matplotlib the only library? No, there is Plotly. So Plotly by itself is a very interactive data visualization tool. So yeah, you may also consider that. I think it's not actually, it's the paid, they have it's not open source, but there's also Bokeh. I think that's also another data visualization to consider. Usually you go to the gallery to see some insights. Let's see, for instance, this, usually they have interactive data visualization. For instance, if I can see, it gives me a tooltip, as you can see, and this can be embedded with the website on the web. And you may change different parameters, and it's just to show, I don't know what this means. And even as you can see, you can maybe even, I managed to scale the, okay. Let's see another more insight about this. This is something to consider, especially if you are a web developer, because you can connect this with, for instance, something we didn't do this, box plot. It's straightforward. Just you use the box plot and you can visualize the different quartiles in the 50th quartile of the box plot. That's also possible with Matplotlib. Yeah, I think with this we have to close our Matplotlib lesson. Yeah, that is it what we have. And next week we will just work with data, and it's going to be pandas. We learn pandas at the same time we work with the data. Maybe I can share with you data in advance. Yes, thank you.